হয়েছে? এই তো লাইভ দেখাচ্ছে। বাইশ ঘন্টায় লাইভ হয়নি। কি প্রবলেম হচ্ছে? কোথায় লাইভ হচ্ছে কিছু দেখাচ্ছে না। কিচ্ছু দেখাচ্ছে না।
লাইভ দেখাচ্ছে
শেয়ার করবো, সমস্যা নেই।
চ্যাট বক্স অন আছে?
চ্যাট বক্স অন আছে। শেয়ার করে দেবো না? পিপিটি করো।
এখন 50 টাকা নিয়ে রাখ। এটা বাইরে তো এটা রাখ তো ফার্স্ট টাইম।
A warm good afternoon to all and one present over here. It is my great pleasure to welcome you all on the second day of Summer School of Emerging Technology, SUSET 2024, organized by the Department of Information Technology in association with the Internal Quality Assurance IQAC of Haldia Institute of Technology. Yesterday was filled with insightful sessions and engaging discussions, setting a solid foundation for the rest of the program. Today, we will continue this journey of professional growth and academic excellence. Along with that, we are heartily welcome our renowned speaker, Dr. Joshna Kumar Mondol. We look forward to your session and the valuable insights you will provide, which will undoubtedly enrich our understanding and professional practices. As we embark on the second day of SUSET 2024, let us continue to embrace the spirit of collaboration, learning, and involvement. May today's session be as impactful and inspiring as those of yesterday, and may we all live with new knowledge, skills, and connections that will enhance our professional journeys. Once again, welcome to the second day of SUSET 2024. Let's make this day a memorable and enriching experiences for everyone. Without further ado, I would like to call my colleague Mrs. Tamusha Chakraborty to felicitate our speaker, Dr. Joshna Kumar Mondol, with a bouquet of flowers. Thank you so much. It is my great pleasure to welcome Dr. Joshna Kumar Mondol, a distinguished scholar and esteemed academician, to our event today. Dr. Mondol's impressive academic journey and significant contributions to the field of computer science and engineering are truly remarkable. Mr. Dr. Mondol completed his M.Tech in computer science from the University of Calcutta in 1987 and was awarded a PhD in engineering from Jadavpur University in 2000. Currently, he serves as a professor of computer science and engineering at the University of Kolkata. His career is marked by numerous leadership roles, including serving as a Vice Chancellor of Raiganj University in West Bengal and as the Dean of Faculty of Engineering, Technology and Management at Kolkata University for two consecutive terms from 2008 to 2012. He has also been the Director of Internal Quality Assurance IQAC and the Chairman of the Center of Innovation, Research and Management at Kolkata University. In addition to his leadership roles, Dr. Mondal has an extensive teaching and research background. He has supervised 30 PhD degrees with 8 more students currently pursuing their doctorates under his guidance. He has also supervised 3 MPhil students, more than 80 MTech students, and over 130 MCA dissertations. His prolific research outcomes include more than 450 published research articles. Recently, Dr. Mondal published a textbook on reversible steganography and authentication via transform encoding with Springer, which has been translated into Chinese and republished in China by Springer. He has organized more than 60 international conferences and served as a corresponding editor for conference publications and edited volumes with prestigious publishers like Springer, IEEE, Elsevier, editing a total of 60 volumes. Dr. Mondol has completed 5 research projects, receiving grants from AICT and the Government of West Bengal. He has held numerous notable positions, including past secretary and the chairman of IETE Kolkata Center, ex-governing council member of IETE, chairman of the CSI Kolkata chapter and CSI Siliguri chapter, and peer team member of the NAAC accreditation process. He has also served as an expert member of AICT EBC and conducted academic audits of various universities and institutes. Dr. Mondal is a member of ISO, IEC, GTC1, AC36, WG8 for Learning Analytics, Interpretability, and the member of the Bureau of Indian Standards, LITD 17, 19, and 36. The Higher Education Department of Government of West Bengal confirmed upon him the Shiksha Ratna Award for Outstanding Performance in Education in 2018. He will serve as the ISO convener of the working group ISO GTC 1 SC36 WG7 for IT LED, culture, language, and individual needs for the next 3 years. Notably, Dr. Mondal has the highest number of Scopus-based journal publications with 203 publications in the last 10 years among all the faculty members of the University of Kolkata during 2013 to 2022. His total SCI SSCI publications in the last 6 years amount to 41. We are truly honored to have Dr. Mondal with us today. His presence and insights are invaluable and we look forward to hearing his thoughts and experiences. Join me in giving a warm welcome to Dr. Joshna Kumar Mondal to the stage. The stage is all yours. Sir, please come.
So, good Good afternoon, everybody. I hope I'm audible to all. So, fine. So, I'm honored that I've been invited to share some of my thoughts and some of my works in the last, I think, 10 years with my scholars. And this is one of the area. Normally, we have started the work when these sorts of neural computing and deep learning, it was not in the place. But we have started the work. This work, whatever I am doing, this is one PhD work of one of my inspired scholars, mostly embedded from there only. And this complete thesis you will be getting from Sodh Ganga Kota also. So not with this name, some other name maybe. So and I try to enlighten you about the state of the art methodology. Because nowadays, what I could see, I'm sorry to say, I should not say this, and because AI empowered tools are there and we are using extensively. But what's the problem? You can notice that problem that we are using, mostly we are using Python and mostly we are using the functions. And very few of us trying to get into the function and try to impart a data X incremental value addition on that. Mostly we are going for the analytics of the data, not the analytics of the procedure. Whatever procedure is written, that means most common terms in school children can take that CNN, RNN, random forest. But the thing is that my suggestion and my request to all of you, because we are in the, I think I was talking with the HOD that we are in the last lap of our career. So someone will bombard us and I will go out from the orbit with the system. But you will take the arena and you will take the lead. But the leadership will come in terms of some addition. Not only analysis of the data, but also analysis of the methodology. Whatever methodology inside the RNN, what is the convolution layer, what is the maximum layer, and how can I give a delta X addition on that layer? What was the problem for that, or what? How you can improve it in some methodology? I request to all of you that you go through it. Then you will see that the paper will be functional very good. Not only data. That means a lot of places I used to see that when I am going for review the paper in the journal, the thing is that I used to see that they are taking the data from Kaggle, data from X, Y, and then analyzing that this data is giving best result, this data is not giving good result. So in addition to that, if you make a value addition, I'm not telling you that you don't do that, but my suggestion is quite different. That if you can also suggest that if I change the max pooling layer from this point to this point in the delta X, then I'm getting an improvement. That is the base improvement, not improvement in terms of the data. So when we have started this research on the inspired fellowship of one of my scholars, so I'm honored and I used to say this scholar is now in the Belur Ramakrishna Mission as a faculty member there. We have started this work in 2009 and we have completed this still now it is going on, some of the students are working on that, but this work we have implemented all the program, all the tunings and others in Java. And we have written explicit Java RMI program for simulating or whatever result you will see, everything will be there, not using a single function. And secondly, my last part of the talk will be based on the test bed. Nowadays you are going for various results and various comparison with the existing results. But Particularly, my domain will be based on the security. I'm not going to other domain. So I restrict on the security domain, well as the security domain. And there, NIST has described a white paper. I think that NIST site is providing that, you can download that. All methodology, complete mathematical details are there. You can implement that also. So I have implemented that, we have implemented that. 15 days NIST has there, particularly based on the random number generation and the various aspects of the image processing and image security and all other things. So that test I will show you. That after my tuning and various tuning methodology, I shall show you that NIST test bed, how results are coming. This is site is very large, almost 250 slides are there, and I cannot go there directly, but it will be a tutorial for you if you can go for it. So I have already given the slide, anyone can take the slide. Even the thesis is also available in the that Solponga portal website, that you can download it. But if you can value add for this, I'll be happy for that. So even what my intention here is that you see that I'll start from a single one layer, one hidden layer tree parity machine, and then I will gradually increase the hidden layer, and I will show you the analysis of the result. Most of the cases we have increased the complexity of the computing, but the thing is we see that the tuning time is get reduced. Why I am taking 16 layer, 14 layer? Most of the cases we are using 16 layer. When I am excluding and convolution, that layers mostly 16, 18, 20 layers. There number of layers. Now, have you thought how these layers are time effectively computing the system? My scenario is being generated from there. So that I will show explicitly in terms of Java programming and output from the Java. So, and what is my intention here? My intention is that we have, I think since 2003, one domain has come into the system. That is when we have started the security alongside of the communication of our system, communication of the message through devices. So earlier it was the mainframe computer, then desktop computers, then handheld devices, now then any IoT devices. But whatever we are doing, we are going for a communication. So now we have imparted the security of the communication. How we have imparted the security? Mostly in terms of two things we have imparted the security. In terms of the encrypting the message, that means I am enveloping the message and then decoding the message. And secondly, we are providing the security in terms of the key. But when I am enveloping the message, so there is a, yeah, you can see, so when I am imparting the message into an envelope, I have some algorithm. And among some algorithm, we have some key. Now mainly, I am focusing that problem. What is the problem? The problem of key. Because if you are going for a simple symmetric key cryptographic system, in that case, I have a single key. I am sharing that key. I have a slide, I will show you later on. And when I am going for public key cryptography, the public key cryptography is very useful. You know that we have a pair of key. And we have a key exchange technique. This is a Diffie-Hellman key exchange technique that we normally use. That uses mathematical computation to compute the keys at both ends. Without exchanging the key, we are computing the key. And same keys are generated. But it definitely suffers from the man in the middle ladder. Who is that in the middle? So I think it will not be below here because of this smart board. So you see that now eavesdropper is here. So if I am here, now I am here. I cannot see this side. But if I am here, I can see that side and this side. This is called the man in the middle. and the attack is called the man in the middle. That means when I am exchanging the key, when I am exchanging the key, if the key is intercept during the exchange, then you see you are sending key 2. I am taking 2, I am sending 3. 3 is received. But the receiver or sender never know that 2 has been sended but 2 did not receive. Or 3 has been sent but not 3 has been sent. So that confusion cannot be overcome in terms of this deferment key exchange. This is a problem of the deferment key exchange technique. That is a man in the middle attack. Now, what is the solution for that? So, researcher thought that, you see, another thing is that when this research was started during 1960, 55 onwards, this research was started. So at that time, it was, I think, Bush Senner. You have, I think, know the name of Bush Senner, who was the pioneer of the cryptographic field. At the beginning, we have thought that some symmetric computation will be sufficient. What is the symmetric computation? I am giving one example. That you have simple exclusive operation. So if you have 2 bytes, and if you go for exclusive operation, you will get the 3rd byte. So you strip off the 2nd byte. You again go again another exclusive operation. You will generate the 2nd byte. In the cyclic form. Your symmetric encryption mostly cyclic form. That means only you can go forward directions, you will get. It will form a cycle. In somewhere, it will form a cycle. I have a lot of algorithms from my scholars. You can see that that algorithms are there that we can generate. But what is the problem there? Here you see that if cycle is formed in 8 iteration, so 4th iteration I can take as an encrypted string. But 4th is a key. 4 I am talking about, 4 means it's a key. So I have to exchange the 4. So my intention is that how to reduce the exchange of the key and how to generate the key. This problem, yeah. You have some encryption, decryption. I'm just skipping this very quickly. I have already talked about this. So we have the symmetric and asymmetric. So in both cases, either 1 key or 2 key, pair of key, it has to be exchanged. So this can be done using encryption and decryption, and my problem is here, that sharing of the key. How do I reduce the sharing of the key? Can you have a process to generate the key at my end? Then what will be the process? So first, I think this research paper came in 2002, I think. And then one field has been emerged. It is called the neural cryptography. Another field of security, it is called the neural cryptography. So I am just going to deal with the neural cryptography, starting from a single hidden layer up to 3 hidden layers, and starting from normal binary based system, then some system where I can use the chaos theory. You know, chaos is a nonlinear dynamics where you see your input and output is both functions of the same variable. So how to use that chaos theory, and significantly this chaos theory is being used for security, particularly in terms of generating the random numbers and to qualify that this is your true random. So I'm having that how much I can go, I don't know. Yeah, these are some of the techniques we are using. The payment casing already have discussed. Let's go for that. And another thing is that other than security, we have the authentication also. So what is the difference between security and authentication? The first thing is that suppose I am providing enveloping of my source information, that means my message, using some key. The receiver will get the key in some private channels or other channel, and then it will be decoded. Fine. But suppose I am sending my angiogram or my heart to a doctor so doctor received the angiogram. Now can doctor ensure that it is my angiogram, not the angiogram from middle? Someone has taken my angiogram and it has been uploaded some other angiogram. So then it will be a kasapa. That means non-reputation. How do we ensure the non-reputation? That is your authentication. That means how can we go for it? No, at last I think if I get some time I'll show you. You see that suppose I am generating one hash. That means I am computing. So this is an image. Absolutely, I can take some frame. If it is a video, then I can take the master frame, and I am generating a message from that. Okay, and I will embed in some places of this angiogram, and I can also send this through a private channel or secure channel. So the doctor received. Again, doctor will generate. Is called the one-way hash function. So doctor will generate the hash function again. So it will compare, and then it will take that message from the third-party channel, and again it will compare. So it is called the three-party authentication system. So if all identical, then I can say that it is the source of non-repudiation is satisfied. So that is called the authentication. Here we are not going to envelop, we are not going to encrypt the complete message. So security and authentication is two different and separate fields. So don't never coagulate these two into one. Because there we are not involving the complete text. Rather we are computing one-way hash function. We are computing the one-way hash function. So that's why I have given this here authentication and encryption separately we are dealing with. So this hash we normally generate in terms of a signature. What is the signature? Here signature is not a signature, it is a generated code from a given message. If message is altered, code will be altered. So we have the SHA or MD5. So that type of things we used to go for your message digest. So whatever be the problem, whatever I think I could give some idea about this encryption and authentication. So whatever the problem is that the key exchange. So this is my problem today. So how do we go for reducing the exchange of the key? So that you see that we have the literature, some of the surveys of the literature here I have given for your reference 2002. It was the first paper on the neural computing and neural cryptography, particularly neural cryptography. So now my proposal is that we can go for the key generation using neural computing in terms of tuning of the neural network. That proposal mostly which I did for rest of the lecture. First, let us consider a T-parity message. What is a T-parity message? We have some input layer, we have some middle layer, and we have one output layer. Most of the cases. So what we normally do in your T-parity machines, some of not coming. Okay, it's okay. So this is, I think, one example I have given in my book. From that book I have taken this. You see, I am initiating two machines, identical neural network, into end of the communication. So what we was doing, we was trying to exchange my key, but here we are trying to tune the network instead of exchanging the key. How? But can you say that I can completely avoid the key exchange? No. What I am doing that I have one output layer, number of input layers and number of intermediate nodes, and we have some edges learning methodology. Maybe Hebbian, maybe anti-Hebbian, maybe random ones. So I have used our methodology use three learning rules. lot of other learning rules are there, you can use their learning rules. So my experiment is based on these 3 learning rules. So this is the book, I think this is the reference of the book. So during the lockdown, this was my product. So I have written, I was in the home, I was very exhausted and bored, and then I have written this mathematical computation. Complete book is the mathematical, all reversible computations are given. And I think 6 transformations I have used. And reversibility of each transformation. And from then, after that, some computations, maybe authentication, maybe security, whatever. Mostly steganography things I have used. I think even I have used the Z transformation and your complex conjugate of the Z transformation, we have embedded some security code. So that is also there. So this book is there. So you see, this is the tuning methodology. We have written the program in the Java that we have simulated. You see 2 networks. This is one and this is another. And we have some hidden layers, we have some input layers, and we have some weight vectors and synchronization. Is at the beginning no synchronization. So gradually it synchronizes. You see? Sorry. Yeah. You see, both of the networks are identical. We have synchronized. So we have the Linux-based systems and Windows-based systems. So you see, VMware if you can use, so if in your single machine you can do it. No need of multiple machine. So your Windows are there, and your VMware you install, you will get another window there, another system will be there. So parameter exchange you can go for it, and that's protocols also written here. I'll just show you. It's not possible to explain all these things. So you can tune. Once the network is tuned, that means now I can take any path edge for computing the key. That means totally I am computing the keys using the network. These are some of the objectives. Some statistical tests at the end we have gone for it. Some randomness test we have also gone for it. Some predictability things we will discuss. And random number generation also we shall discuss. I don't know how much it is. Yeah. And you see that most of the cases we are using class 0 and 1. When I can go for the input vector for -1 to +1 in any network. But if we use the binary input vectors, that means I am talking about the binary random input vector. So if it is a binary random input vector, how do we ensure that? That is also very important. I will come to that. And another thing we have used is a chaos assisted random number generation. This chaos is a nonlinear dynamics. What is chaos theory? You see, this is the function x k plus 1 equal to f x k. That means your right hand side and left hand side are both function of same variable. Then what is the solution for this type of nonlinear dynamics? The thing is that you have to take 2 parameters. One is called the system parameter and other one is called the starting point. Yeah. You see, this is one. That means I have, it's called the map, chaotic map. This is called termed as the chaotic map. When we are going for the chaotic map, so you see we have some dynamics. So any chaotic map used to so you see this map used to generate a real number, not any binary number. Any chaotic map or any chaos equation will give you a real number. First thing. And then you have to use a mapping function. What is the mapping function? That you see, this is one mapping function. That you see, when I have generated 2 series, suppose one series. 0.555, 0.526, 0.576. So 5552 and 57. So that means 55 if you give the 0, then if it is less 55 then it is 1. You are posting that into 0 and 1 from random number to the binary number. Random number is between 0 to 1 real number. Okay? So that means now you are generating 0 and 1 using chaotic equation. What the chaotic equation give? You see, any chaotic equation, you have the function of x with some parameter alpha. It is called a system parameter. So you have to make a guess of this system parameter. What is the guess? You see in lot of books and the literature you will get that what is the value of alpha of this equation so that the number is random. But here you have a problem domain. You can use genetic algorithm to optimize the parameter that what value of alpha that it gives a true random number. That is itself a problem. You can use PSO here. That is itself a research area. It's not like that. I am taking 0.5. Mostly we use that is the from the middle. But this is you can use genetic algorithm. You can use a generative AI to go for all these things so that your good parameter will be generated. So one step will be to generate the good parameter, and then next step will be use that parameter to generate the random number. Then you use the fabrication function for your generator.
Sir, why this mapping system is called QK?
No, various maps are there. So I cannot show you. It is not here. I think why it is called here. Skewed is like a skewed a triangle. It's like a tent, and it is skewed in some direction, either vertically left or vertically right. That's why the name of this map is called the skewed tent map. So other maps are other tent maps, normal maps, one-dimensional chaotic map, two-dimensional chaotic map, three-dimensional chaotic map. So lot of chaotic maps are there. Nowadays, in lot of cases, we are using chaotic situations. Now, what is the facility for this chaotic situation? I am talking about the chaotic. The word chaotic is used, but it is completely ergodic. What is meaning the ergodic? That means if you know the system parameter and initial value, same data will be generated always. That means why I am interested on that? Because suppose I am giving 0 1 0 1 as a random number in my data.